Hello. Hi. Wow, thank you. It's going really well so far. That's good. Yeah, so my name is Mike Engel. You can find me in maybe like 50% of places as Vegemike. The other 50 are random usernames that I found. So today I'm going to talk about defensive programming, or how flying can relate to programming. So I guess a little less than a year ago, I decided to try and get my private pilot's license. This is the plane that I usually fly. It's built in 1979, and it still runs like several hundred hours per year with students flying it, so kind of like a rental car. I don't think you'll find very many rental cars from 1979, so I would say that airplanes are generally very resilient, and while still prone to failure, they've taken a lot of steps over time to try and reduce those ahead of time. This is me trying very hard not to crash the airplane as my instructor suddenly whipped out his phone. And so when we talk about resilient systems, airplanes, they have a lot of moving parts, any parts of them to fail. And so while there can't be, say, two sets of wings or generally two tails, a lot of internal systems that are very important to ensure that you go from point A to point B have multiple redundancies. So here, these are the hydraulic systems that power like how you turn the airplane or how you go up and down. And here, these are three different systems that do the exact same purpose. So if one fails, it just falls over to the next one. And if that one fails, then it falls back to the other one. So over time, they've learned how to make these things very resilient and catch errors. And they don't assume that everything is going to work. They actually assume that most things will break. And so trying to figure out how to gracefully handle failure is a big part of designing and flying an airplane. So the other side of the camera, this is the panel that I see every time I fly. There's no infotainment system. I can't plug in CarPlay or something here. Like, everything serves a very distinct purpose to tell me that everything is fine, or to very quickly tell me that everything is not fine. And so not only are there redundant systems in the plane itself, but there's also a lot of feedback to me as the user of the airplane, so I can start catching things early before it gets bad. And here is one example on a larger airplane. Is like, if your engine starts on fire, a red thing will light up and say, hey, you have a fire in your engine, you might want to do something about that. And thanks to redundancy, you have another engine, luckily, so you're not just going to fall out of the air, which is, of course, always good. So yeah, the process of, like, before you even get into the airplane, you have to do all of this. And again, not assuming that anything will work. And so every time, it takes forever, and it's super annoying, but also it serves a very special purpose where you go through and you manually touch everything and you check everything on this list. And then once you actually get inside, then there's a whole bunch of other things that you have to do. And these things aren't simple, like turn on the engine. They're more like, put the key into the ignition, make sure that you have gas, turn the key to the left 2 spots. So it's very specific and very step-by-step, checking every step and not assuming that you know what you need to do. And it also tells you what each status, sorry, this is like really blurry, but each thing has an expected value. And it also has failure checklists. So if your engine is on fire during a flight, what are the steps that you need to do? So it's very explicit. So how do we apply that to code? So here's a very simple example of a method on a class that goes and gets some data and returns the first user. So what happens if the network is down or your backend suddenly starts crashing? In this case, just like all these rules that I just talked about with an airplane, the goal is to not have the thing crash. So you don't want an airplane to crash. You also don't want your application to crash and your user just sees a blank page. That's a terrible user experience for them. So if we start thinking about defensive programming, we want to prevent a crash. So what can we do in this case? The very first thing we can do is wrap it in a try and catch. So this will prevent a crash. So very basic, your user will see no feedback, not great. So this would be like a very full thing, very defensive. So here, maybe your filters are coming from the URL query and maybe they don't exist. So first you check if it even exists, and if not, then you return early. So then you know that filters is there, probably an email. Then down there, let's see, laser pointer. Here, have a nullish question mark to make sure that users actually is returned from the fetch. And then here, if you get an error, you can return it to your error logging system, or you can actually present an error message to the user with an action for them to actually recover from that and to try again if it was intermittent or something like that. Yeah, so sometimes things do happen and you have crashes. Transportation boards, they do like accident reports and they spend months or years writing this stuff up. The most important part is here at the end when they have a list of conclusions of like why the crash happened and their recommendations for, to make sure that it never happens again. That's the main goal, is that it never happens again. So I've had several production outages that I've caused. You will probably all do it too. That's fine, it's part of being a developer, but the important part is to reflect and say, why did this happen? How can we prevent this from doing again? The easy way to do that is to write some tests, but then you can also go and look for patterns and try and figure out how to prevent similar cases from happening in different parts of your application or different components. And I think that's it. Thank you.